Assalamualaikum. Uh, for this open-ended lab 3 for this mission, I'm gonna simply brief about this lab. So for the introduction, in this OEL, or we call open-ended lab, we do two important tasks in order to be familiar with main machines like DC motor. The first two part is represent in different forms, which is DC motor, shunt DC motor, and series DC motor. And other than that, we like to investigate and observe the DC separately connected motor arrangement experiment steps to improve the efficiency rate of the motor. So this is the diagram for DC shunt motor where the connection is in parallel, the field connection in parallel, and for the DC series the field is connected series with the supply. So for the schematic and circuit diagram, this represent a DC shunt motor characterization schematic and circuit diagram. As we see the connection from the with terminal voltage parallel with the connection. And this is the schematic diagram on PCM simulator. Same goes to DC series. The connection were series. And this is the schematic diagram on PCM simulator. And lastly, this is the circuit diagram, a schematic diagram for separately excited DC motor, where the terminal voltage and the field voltage are separately connected. And this is the circuit diagram on PSIM simulator. And for the methodology, we did three main parts. We studied about two forms, which is DC shunt and DC series. In a series wound DC motor, the armature winding and field winding are connected in series, and the current through them is equal. So the armature current and current field were equal to I total. But for DC shunt motor, the armature winding and field winding are connected in parallel. So the current in a shunt motor were split into two parts. And for separately sected, the field coil is energized from a separate DC voltage source, and the armature coil is also energized from another source. So for the first part, we observe the relation between parameter like torque, voltage armature current, and speed, and the effect of the changing the torque on the speed parameter. For the second part, we notice the relation between some parameter like resistance, armature current, field current, voltage armature, and speed, as well as the effect by changing the resistance and on the speed parameter for the DC series and changing the voltage on the speed parameter for DC shunt to control the speed. And the last part, which is separately excited DC motor, we notice it about the effect of current and voltage field and motor speed on the output voltage. For the result and analysis, this is the result table for part A, which is to compare the performance of the tested unit in the lab. As we can see, by keeping the resistance constant, the speed decreased somewhat exponentially with the increased torque. So it is clear from the characteristic that the series motor has high torque at low speed. Thus, the series DC motor is used where high starting torque is required. For the current and torque characteristic, keeping the resistance constant when the current of the generator increase. Therefore, up to magnetic saturation, the armature torque is directly proportional to the square of the armature current. So the torque versus armature current curve up to magnetic saturation is a parabola. The armature torque is directly proportional to the armature current. So it is clear that starting torque of a DC series motor is very high. For the second part, which is part B, to determine the efficiency rate of the motor unit in the lab. So this is the result table for part B. This is the table for DC series, and this is for the table for DC shunt motor. As for DC series torque resistance, the graph shows the relationship between the torque produced by the motor and the resistance of the armature circuit. As the resistance will increase, the torque produced by the motor will decrease. Due to the fact as the resistance increases, the current flowing through the armature decreases, leading to a decrease in the torque produced by the motor. And for the current resistance characteristic graph, based on the graph, we can observe that speed increase non-linearly with armature current. When we increase the resistance, the armature current will decrease, hence the load is not directly proportional to the armature current. For DC shunt, the graph shows the relationship between the torque and the resistance. As the resistance will increase, the torque produced by the motor will remain constant. The relationship is due to the fact that the torque produced by a shunt motor is directly proportional to the current flowing through the armature, which remains constant despite change in the resistance. And for the current resistance, for DC shunt, we can observe that speed increase linearly with armature current. When we increase the load, the armature current will also increase. Hence, the load is directly proportional to the armature current. And for the last part, which is we like to propose and illustrate the DC separately connected motor arrangement. So this is the result table for separately excited DC motor, where we measured for value voltage armature, current armature, voltage field, current field, and the speed. At the top, 1 kilogram per meter. So we're gonna compare about the voltage current characteristic. Based on the graph, we can observe that when the field voltage at 120 volt constant and the current field, the speed increase linearly with the armature current. When we increase the voltage, the armature current will also increase. Hence, the voltage is directly proportional to the armature current. And for the second test, we get this result table by changing the field voltage by increasing by 5 volt and the armature voltage by increasing at 10 volt. So the result is based on the result, we can observe that when the field voltage and current increase, the speed decrease linearly with armature current. Hence, the speed of the motor inversely proportional with armature current. So it can be observed that torque produced by the motor remains constant despite change in the voltage armature and field, while the current decreases as the voltage armature and field increase. This observation can be used to control the speed of the DC separately excited DC motor by adjusting the resistance in the armature current and by increasing the current. The speed of the motor can be decreased, and by decreasing the current, the speed can be reduced. So that's how you control the speed for separately excited DC motor. So this is the conclusion. For this OEL, shunt motor has a slightly different operating characteristic than a series motor. So the shunt motor speed can be controlled. The ability of the motor to maintain a set RPM at high speed when the load change is due to characteristic of the shunt field and armature. So this is will allow the difference between the back EMF and apply voltage to become larger, which will cause more current to flow. The shunt motor RPM also can be controlled by regulating the voltage that is applied to the motor armature. The torque of the motor will be reduced when it is operated below the full voltage level. At the end of the experiment, we are able to compose, simulate, analyze performance and the characterization of a shunt connection and a series connected motor using PSIM simulation tools and a physical approach to the contact lab session at the past. And for my recommendation, when choosing between a DC series connected motor and a DC shunt connected motor, it is important to consider the specific requirement of the application. For applications that require high starting torque and low speed, such as in trains and hoists, DC series connected motor is recommended. And for the high starting torque allows for heavy loads to be moved with ease, and the low speed is suitable for this type of application. However, for applications that require constant speed, such as less and pump, DC shunt motor is recommended because the constant speed is ideal for this type of application where precision and consistency are important. In any case, it's always recommended to consult with an expert in the field and testing different types of motor in a controlled environment before making a final decision. So this is my reference for this lab, and that's all from me. Thank you.